So we've been spending the last few days talking about different parts of the electromagnetic spectrum. We learned about waves that have frequencies lower than what humans can see. We spent a day talking about visible light and how the different colors can combine together to produce different effects. Today we'd like to focus on the bottom part of the spectrum. Those three types of electromagnetic radiation that involve frequencies higher than what the human eye can see. So the first one is called ultraviolet light. And with ultraviolet light, the reason you've probably heard about it before is because of the ultraviolet light we get from the sun. About 20% of all the light that comes off of the sun is ultraviolet. Each day, you're going to get different amounts of ultraviolet reaching the Earth's surface depending on the time of day, depending on where the sun is, depending on how much cloud cover there is, and what type of clouds we actually have. Because it changes from day to day, part of the weather report might be an ultraviolet index. I'd like you to know when you see an ultraviolet index between 0 and 2, that means there's minimal risk from the ultraviolet light. When you see an index that ranges between 10 and 15, that's when we have the most severe risk from the ultraviolet light of the sun. When it's 0 to 2, minimal precautions are all that are necessary, and you could probably be out in the sun for an hour or more without experiencing sunburn. However, on those most dangerous of days, as little as 10 minutes of unprotected exposure could cause your skin to burn. You'll notice the precautions you need to take are much more elaborate to help protect yourself from this UV light. You may have also heard that the UV light from the sun can come in different flavors, I guess we could say. And those would be UVA, UVB, UVC, and you could also have extreme ultraviolet. Now, the extreme ultraviolet is not really produced by the sun, but humans can create extreme ultraviolet light. Each of these types of ultraviolet light has slightly different characteristics based on the wavelengths and frequencies. So for UVA, it is the least energetic of all of the UVs. The extreme ultraviolet is obviously the most energetic of all the ultraviolets. Okay, when we look at the ultraviolet coming off of the sun, and again, 20% of the light coming off the sun is ultraviolet. Not all of it is going to reach the Earth. In fact, you'll notice all the UVC that is produced by the sun gets absorbed by our ozone layer, and pretty much 0% of UVC gets through, which is a great thing because UVC is extremely dangerous. UVB, most of that gets filtered out by our atmosphere. A little bit does get through, and that little bit is actually beneficial in small doses. It helps us produce vitamin D. Again, being exposed to too much UVB is going to start to damage the skin. Same is true of UVA. Even though it's not the most energetic, it can actually penetrate the farthest into our skin, and over time it can cause damage. It can cause skin cancers and burning, okay, to the skin. All right, so these are your different types of UV and how much of them actually reach the surface. 95% of all UV that reaches the surface is going to be UVA. 5% will be UVB, and 0% will be UVC. Again, those numbers might change slightly depending on atmospheric conditions. Why is UV light dangerous? Well, UV has so much energy that it can actually rip apart our DNA. That's as bad as it sounds. Okay, ripping apart our DNA can cause the DNA, when it tries to fix itself, to introduce errors into our code. This can lead to things like skin cancer. Okay, so the energetic light can rip apart our DNA and it can damage our cells. So you want to minimize your exposure to this type of light. Having said that, they do produce light that people buy that intentionally creates UV. It's UVA. They're usually not very powerful, and they serve a purpose. So the UVA light is called the black light, can energize some materials, and then when the materials fall back to ground state, they will give off light that we can actually see. So for instance, if you shine this UVA on the certain minerals, those minerals will start to phosphoresce in different colors. Okay, so it looks really cool. And again, this is all natural, but it's something that we would never see because we would never be in an environment where they're being hit with simply UV light. Again, we can create this. So if we go down into a cave that's made of these materials and we shine UV light onto the walls and we turn off all the other types of light, we will see the walls of the cave start glowing in these awesome colors. It turns out that there are a couple places right in New Jersey where you can do this. They're in northern Jersey. It's the Sterling Hill Mine and the Franklin Mineral Mine. And they're closed now because of our COVID protocols, but soon they will be reopening, and I would encourage you to go visit and check them out. They're pretty cool. Okay, in terms of UVC, we sell those lights too, but they are not meant to be shined on the human body. They are way more dangerous than any of the other types of UV that we talked about. However, they're so dangerous that they can kill things like bacteria. So sometimes you want to buy things that will sterilize your electronic equipment without having to immerse it in any kind of fluid. And the best way to do it is to immerse it in UV light. Not any type of UV, but UVC. Okay, the UVC is so energetic, anything that was living on your electronics will be immediately killed. They do this in hospitals. Again, they would get everybody out of the room, and they could sterilize the room by bathing it in UVC light. Some airlines are actually working on this also, where they would run this system of UV lights through the cabin after everybody has deplaned, and it would be able to kill anything that's lingering behind. Okay, so in summary, UVA is the most common type of UV that reaches us from the sun. Long-term exposure can cause skin aging and skin cancers. UVA is also used for making things phosphoresce or fluoresce, okay, by shining light on them and having them give off light of different colors. UVB, that helps us make vitamin D. It is also something that can cause skin cancer, so we have to be careful of our UVB. UVC can be used to sterilize. This is something we never want to expose our body to. Extreme ultraviolet, we didn't even talk about because it doesn't really have that many uses. It is so energetic and it has such a high frequency that it is bordering on X-ray. So it is really close to being as dangerous as X-rays, but not as useful. Because X-rays turn out to be really useful, as you know, because they can go right through the human body and be blocked only by the bones of the body. So they can pass through things like the skin, the muscle, the blood vessels, and allow us to see what our bones are looking like. X-rays were first developed back in the late 1800s by a person named William Roentgen, and almost immediately found their way into the medical profession, and they've been there ever since. They are dangerous, so you don't want to be getting X-rays just for the fun of it, but a moderate number of X-rays can actually be very beneficial. Okay, we also use X-rays in the astronomy field because there are some things in our universe that are so energetic that they produce X-rays. And by having X-ray telescopes, we can see what these objects are doing in that high energy range of the spectrum. Some things are even more energetic than X-rays, and they are known as gamma rays. Again, they have two main uses. One is in astronomy. We have gamma telescopes, which allow us to see the gamma rays being emitted by different sources throughout the universe. Okay, which is, again, really energetic objects in space. And gamma rays can also be used in the medical profession. Not like X-rays, not to image the body, but in the hope of using that high energy focused on just the right spot to be able to kill tumors. This is really delicate work because you don't want to hit any area of the body other than the tumor. Okay? But the gamma is so energetic that the hope is by focusing all the energy on that one spot and having it high energy gamma rays that we can destroy that tumor. Okay, so hopefully you have a little better feel for all the different regions of our electromagnetic spectrum. Radio for astronomy and communication, including our Bluetooth and our cell phones and our Wi-Fi. Microwaves, not just for cooking, but also for communication. Infrared, we saw that was for being able to see things that are around room temperature. They're giving off infrared radiation, and we could see it using special cameras. We have our visible light that we went into, talked about the different colors and how to combine them. And today we saw the dangers and benefits of ultraviolet, X-rays, and gamma rays. All of these different bands help us live our life a little fuller, but they each have potential downsides. So you have to be aware of both the pluses and the minuses of the different areas of the spectrum and know how to use them.